Yeah, welcome back. In this class we are going to discuss about Cmos inverter layout. Now in this screen you can observe that I am going to start this lecture with an Cmos inverter. Okay, now you can observe that here it is a Cmos inverter, which is a combination of PMOS and NMOS, that means pull up and pull down networks. Okay, you know very well, okay, in the stick diagram class, how the schematic is going to be converted into stick diagram. Okay, if you didn't watch, please go and watch the video and get a clear cut idea regarding the stick diagram of CMOS inverter. Now here I would like to explain about the layout, how to draw the layout of CMOS inverter. If you are thorough with the stick diagram, it is very easy to you to draw the layout of CMOS inverter. Now you can observe that here there is a demarcation line present here. You may observe this is a demarcation line. Okay, this demarcation line is going to be represented as, okay, I explained that in the monochrome encoding table. This demarcation line is going to be represented as well in the layout. I hope that are you clear. Now you can observe that one more important point I would like to discuss here. Okay, when you are going to give this VDD connection, this is your VDD substrate connection with a cross mark, and this is your VSS connection, substrate connection with a cross mark. But in the layout, when you are giving VDD connection, okay, you have to give N-type diffusion. When you are giving VSS connection, you have to give P-type diffusion. I hope that are you clear. That is an important point. First point you have to remember. Coming to the second important point you have to remember. The second important point is, very importantly, wherever there is a P diffusion, that should be covered by P mask. That is an important point. Once again you have to talk about. This is a second important point. Wherever there is a P diffusion, that should be covered by P mask. I hope that are you clear. And coming to the third important point, that is already discussed. Demarcation line is replaced with a well. Okay, demarcation line is replaced with what? Well. Okay, now VDD is going to be given with which diffusion? N diffusion. VSS is going to be given with which diffusion? P diffusion. Wherever there is a P diffusion, it should be surrounded by what? P mask. I hope that are you clear. Now shall we see the layout of CMOS inverter. Now you can observe that first I would like to have a polysilicon. Now I am having a polysilicon. You can observe very clearly. Okay, this is my polysilicon. It is going to be represented like this. Now I should cross a P diffusion. Shall I take some? Okay, in this manner. This is a P diffusion. It should be widely separated. I hope that are you clear. Now I have to take an N diffusion. Now you can observe this is my N diffusion. It is closely separated. I hope that are you clear. Now I have to give a VDD contact here with the help of a metal. Therefore, how to give this one? Observe very carefully. Now you have to take a contact area here. And you have to represent contact cut. Very important one, contact cut. I hope that are you clear. And you have to give metal. First of all, you have to represent metal. Later, that is an important point, you have to give N diffusion. That is an important point. Okay, now you can call this one as VDD. And similarly here also you have to take a contact area and you have to, yeah, absolutely. What is this? Contact cut. Then after that you have to take metal. Yeah, after that which diffusion you have to take? Absolutely, P diffusion you have to take. I hope that are you clear. Then you can observe this portion is completed and this portion is completed, right? Now what is the remaining portion? Yeah, this one. This is the remaining portion for you. Therefore here I am taking a metal. I have taken a metal. Okay, I have to give contact here. This one. Remember, it is not a VDD or VSS contact. It is a normal contact. You have to give normally, right? Okay. What is meant by normal? You can observe now itself. You have to take, first of all, take the contact area. Okay, and as usual, what is this? Absolutely. What is this? Contact cut. Then you have to draw metal. And you should not take opposite diffusion. You should take whatever the diffusion you are having. Which diffusion it is? P diffusion. I hope that are you clear. Now you can observe that next here also you have to take contact area and you have to represent a contact cut and you have to take a metal. After that you required which diffusion? N diffusion here. I hope that are you clear. Now you can observe that it is what? Input. It is what? Output. And I already said that very important point. What is the very important point I said? Yeah, absolutely. Wherever there is a P diffusion, that should be covered with what? P mask. Where is the P diffusion available? Here the entire thing is, yeah, first of all let me extend my polysilicon to give a clear cut idea for you. This one also I am extending. Okay, now you can observe that wherever there is a P diffusion, this entire thing is a P diffusion. Therefore I have to surround with what? Absolutely, I have to surround with, what is this? Can anybody try to tell? Absolutely. What is this? I will use black color for easy identification. This is what? P mask. And one more important point I said, instead of this demarcation line, okay, we have to use well. Let us decide yourself which well you are going to use. If it is N well, don't forget, in N well which transistor will come? PMOS. The entire PMOS will come. I hope that are you clear. If it is a P well, if you consider P well, then which transistor will come? Absolutely, NMOS transistor will come. Then it is your wish. We have to take. Now I am assuming that it is a P well. Therefore I am taking the entire NMOS in this P well. I hope that are you clear. Now one more important point we have to remember. Here there is a P diffusion, therefore you are having a P mask here. But don't forget, here also you are having, what is this? Can anybody try to tell? This is VSS. I forgot to represent. Okay, here also you are having what? Absolutely. Here also you are having P diffusion, therefore definitely you have to give P mask. This is what? P mask. I hope that are you clear. Now this is the way how to draw the layout, and we have to give the rules for them. Now what is the minimum width of poly? Anybody? Minimum width of poly is what? Yeah, 2 lambda. Yeah, I will minimize the thickness of my brush. Sorry for that. 2 lambda. This is 2, guys. Okay. It is not possible to me to write 2. It is somewhere better. Okay. Minimum width of poly is 2 lambda. Now, can anybody try to tell what is the minimum width of diffusion? Anybody? Absolutely 2 lambda itself. Now, what is the minimum spacing between P mask and contact area? Absolutely, that is also what? 2 lambda. Now you can tell what is the minimum spacing between contact area and well. Yeah, absolutely. What is that? 3 lambda. Okay. Now you can tell what is the minimum spacing between this one. What is this one? Yeah, this one. P mask and P well. Anybody? P mask and P well. What is that? 1 lambda. Okay. Now you can observe that what is the size of contact area? Absolutely 4 lambda by 4 lambda. You have to write 4 lambda by 4 lambda. Is it clear? In this way you have to represent the Cmos diagram layout. Is it understood, all of you? Okay. Now if you what are the bullet points you have to remember? If you are thorough with the stick diagram, once again I am telling, if you are thorough with the stick diagram, it is very easy to you to draw the layout. You have to just replace as it is the stick diagram, and very important point, wherever there is a P diffusion, that should be covered with P mask. And when you are giving VDD and VSS, you have to give opposite diffusion, and demarcation line is replaced with well. Is it okay? Now we will see one more example. Okay, I am taking an example of 2 input NAND gate. You can observe that I am taking an example of 2 input NAND gate. I am using only one color for your easy representation. Now you can observe that. Yeah, sorry for that. I can't able to write 2. I don't know why it is. Yeah, now it is somewhat better. Two input NAND. Okay, now I'm going to draw the stick diagram. First of all, I would like to have this one. I'm going to draw the stick diagram with colors, not monochrome encoding, with colors I'm going to draw. Okay, from now onwards, I would like to have 2 polysilicons. These are the 2 polysilicons. Okay, and I have to grow one P diffusion, and I have to grow one N diffusion. Okay, now I'm assuming these 2 are sources. These 2 are interconnected. Okay, sorry for that. I have to use metal, that is a blue color. These 2 are interconnected, and we require a contact here. Here contact. and VDD is going to be represented with a cross mark. This is what VDD. Okay, and I'm assuming this one as a source. Okay, and I have to give a contact here, and this VSS is represented like this, and these two are connected with what? Okay, the drain combination is connected with the drain combination of A. This one, sorry for that, I have to take black color. Yeah, this is black color, and this is the connection. Is it clear? Very simple. If you want the circuit, I will show the circuit. And first of all, let us this is what A, this is B, and this is Y. Now I will show the circuit. If you want, you can observe here. I will draw the circuit entirely with the black color. This one, this is VSS, this is VDD, and it is A, it is B, it is A, it is A, it is B, it is Y. Now you can observe source should be tied, drain should be tied. Okay, I will use different colors for your representation of this one. Yeah, I will use green color. Okay, source, drain, this is drain. Now it becomes source, it is source, it becomes drain. Now you can observe very clearly. Okay, the source, this one I assumed source, these two are drains. Source are connected, drains are connected, and I assume it is a drain. Okay, then it is source. Are you clear? Then it is drain, then it becomes source. I hope that are you clear? In this way I have represented it. Now as it easily I am representing the layout. You can observe that I am focusing on layout now. Okay, I said okay, while converting the stick diagram into layout, very important point you have to remember. What is that important point? Anybody? Yeah, absolutely. Okay, wherever there is a P diffusion, that should be P diffusion should be covered with what? P mask. And the second important point is when you are giving VDD, you have to take N diffusion. When you are giving VSS, you have to take P diffusion. Okay, is it clear? Now you can observe the layout here. I am going to draw the layout. This is one polysilicon. This is another polysilicon. This is one polysilicon. This is another polysilicon, and it should have a P diffusion, and it should have N diffusion, and these two should tie with what? Metal. And here I required a contact area. These are the general contacts. Okay, you can observe a contact area, and it should be with the contact cut, and I have a V metal here, and normal contact it is, therefore P diffusion. Here also you can observe that, sorry for that, I have to take black color. Here also you can observe that I have to take a contact area, and it is what? A contact cut. Now you can observe that this one is metal, and I have to give P diffusion. But don't forget, here we are having a VDD. Therefore here I have to take a contact area. I have to represent a metal, and I have to take N diffusion. That is an important point. Then I have to call this one as what? I have to call this one as absolutely. What is that? Yeah, I will use black color for a clear indication. This is my VDD. I hope that are clear. Now here also you can observe that I have ESS. Therefore I have to represent a contact area, and this is contact cut, and I should have a metal. After that I should have opposite diffusion. What is that opposite diffusion? P diffusion. Okay, and I should give an interconnection between these two. This one and this one. What is this, guys? Metal, absolutely. Okay, and I have to use contact area. Therefore I have to give the connection here. This is contact area, and here also I have to use a contact area. I have to give connection here. Okay, then later I have to give metal, here also metal, and which diffusion we have to give? Whatever the diffusion we are having here. Why? Because it is not a VDD and VSS contact. I hope that are clear. And you can call this one as what? Yeah, absolutely. This one as A, this one as B, and this one as Y. And very important point is, you should tell wherever there is a diffusion, you should use, wherever there is a P diffusion, you should use what? P mask. This is what? P mask. And don't forget, here also you are having a P diffusion, therefore you have to use what? P mask. And you have to decide well, which well you have to talk about. If it is a N well, entire P mask should be covered. If it is a P well, entire N mask should be covered. Let us consider it is a N well now. Now entire P mask should be covered. I don't have sufficient space. Okay, now this becomes what? N well. Now that's it, guys. You have to give the rules now. What is the minimum width of poly? That is what? 2 lambda. And what is the minimum width of a contact area to P mask? 2 lambda. And you have to represent what is the minimum width of well to contact area, that is 3 lambda. And you have to represent what is the minimum width of P mask to contact area, P mask to well, that is 1 lambda. And you have to represent What is the minimum size of contact area? What is that minimum size? That is 4 lambda by 4 lambda. You have to represent very clearly. If it is not that much clear here, then I will do one thing. I will represent bottom here 4 lambda. And what is the minimum width of metal? Absolutely. What is that? 3 lambda. Okay. In this fashion, you have to give the rules. After that, you have to cross check. When there is a VDD, N diffusion should be there. When there is a VSS, P diffusion should be there. And for VSS, PMOS should be covered. Why? Because there is a P diffusion. And for entire P diffusion, PMOS should be covered. And you have to select your own well. If it is a N well, PMOS should be covered. If it is a P well, NMOS should be covered. I hope that are you clear? Okay. If it is possible to you, give the rules, no issue. This is what 4 lambda, and here also what is this? 4 lambda. I hope that are you clear. That's it guys for the today's class. Thank you very much. If you are having any doubt, you may ask. Is it clear all of you? Thank you for each and everyone. Have a nice day.